This lesson is going to look at integrating our sine and cosine functions. Again, if you remember, the derivative of sine was cosine, so the integral of cosine is going to be sine. Similarly, the derivative of cosine was negative sine, so the integral of sine is going to be negative cosine. We have to deal with that negative on the end. So in this case, the integral is going to get the negative cosine. So again, we're going to need use substitution for these, so just be careful with that. Let's look at a few examples. First one here, integral of sine of 5x dx. We will pick our u to again be that inside part, that 5x. Derivative of 5x is just 5 dx. We don't have the 5, so we'll end up with 1/5 of du is just dx. So again, we're going to kind of go over here. We're going to have the integral of the sine of u, and we've got our 1/5, so we can either put that out front or somewhere. It doesn't really matter as long as it just kind of comes along. So we end up with a 1/5. Integral of sine, we said, is negative cosine, so let's make that a parentheses, negative cosine of u plus c. Pull that negative to the front so we don't have to have the parentheses. We get negative 1/5 cosine. Substitute our u back in is 5x and our plus c. And that's it. Pretty straightforward. Look at a few more examples. I'll help you set this one up, and then I want you to complete it and enter your answer online. We've got, again, u is going to be the inside part here, so u is equal to x squared plus 5. Derivative of that, derivative of x squared is 2x, derivative of 5 is 0. And this is with respect to x. Again, we've got an x here and a dx, but no 2, so we have 1/2 of du is our x dx. And so, again, I want you to pause the video here, finish up this problem, and enter your answer online. A few more examples here. This next one it looks a little bit more complicated, but it's really not that bad. Again, we have this function, 3x squared minus 2x times cosine of x cubed minus x squared. We see that cosine, so we know the first thing we want to try is making that inside that x cubed minus x squared the u, so we'll do that. And when we take the derivative of that, we see we end up with 3x squared minus 2x, which thankfully is that piece out front. If it wasn't, we'd have to either do a little manipulation or try a different method. So, putting this together, we end up with the integral of the cosine of u, and we just have du. We didn't have to multiply by anything there, so it's just straight du. Now we integrate. The integral of cosine is sine of u plus c. Do that last substitution, we end up with sine of x cubed minus x squared and our plus c. Now the last two examples here, we're going to look at definite integrals, we're going to look at areas. Again, with these trig functions, we always have to be careful because they oscillate above and below the x-axis, and so we need to make sure that we're looking for the positive area whenever we go below the x-axis. So looking here again, we've got the integral from 0 to pi over 2. So 0 to pi over 2, pi over 2 is approximately 1.57. So about here, we kind of draw that up. And again, 0 to that point. So we are trying to find our area here. You can see that that is symmetric there. We're actually crossing the axis at pi over 4. And our function here is sine of x minus pi over 4. We can also tell that by the fact that we have that pi over 4 there, if you remember your phase shift from pre-calculus. And so again, this part's negative, this part's positive, so you can see that the areas are just going to cancel out and be 0. But if we're actually trying to find the actual area encompassed by this thing, we would essentially need to make this part that's negative positive, because this is an area here. It's just that it's under the curve. So, and since it's symmetric and it's split in the middle, we can just look at part of the integral, part of the area, and double that when we're done. So let's do that. Let's say we're going to instead look at twice the integral, and it's up to you. I'm actually going to go from pi over 4 to pi over 2 because that's the positive part. You could do from 0 to pi over 4, that's fine. Just keep in mind that your answer will end up being negative, and then you just need to make it positive. Again, integral of sine of x minus pi over 4 dx. Our u substitution here, u is going to be x minus pi over 4. Derivative of that is nice, it's just 1 dx. So we don't really have to do a u substitution in this case. This just ends up giving us twice again because we did this a little bit different. Integral of sine, we said, is negative cosine of that x minus pi over 4 plus c, and we are evaluating this from pi over 4 to pi over 2. So we plug that in, kind of come down here, negative 2 cosine of pi over 2 minus pi over 4 plus 2, because this minus and minus, cosine of pi over 4 minus pi over 4, which is just 0. So again, if we kind of think through this one, okay, so simplifying, pi over 2 minus pi over 4 is pi over 4. Cosine of pi over 4 is radical 2 over 2. And then we have this minus 2 here, so 2 times root 2 over 2. And then plus 2, pi over 4 minus pi over 4 is 0. Cosine of 0 is 1. So simplifying here, 2 divided by 2 is just 1. And putting them in different order so that the negative comes second, we end up with 2 minus the square root of 2, which is approximately 0.5858 if you want a decimal. It's usually better to just kind of leave it as that exact form though. So we've got one more example here. I'm going to help you kind of set this one up, and then I'm going to ask you to enter your answer online in the system. In this case, we have the function y equals sine x plus cosine x, and we want the area of the curve bounded by that curve, x equals 0, which is here, and y equals 0, which would be here. So we are looking for this area in here. So essentially we need to figure out where this is crossing, and we can do that by setting this function that we have equal to 0. So 0 is equal to sine of x plus cosine of x, and moving one of those to the other side, so we'll just say that sine of x is equal to negative cosine of x. Well, that happens a lot of different places, but the first place that it happens is at 3 pi over 4, which is approximately 2.36, which makes sense with where it kind of shows up over here. So that is going to be our bounds here. We're going to integrate from 0, again, that's where we're starting, to, let's leave it as 3 pi over 4 so that we can get an exact answer. And then we are just integrating sine of x plus cosine of x dx. So again, this is going to conclude our video on the integral of sine and cosine. Go online, enter your answer for this example, and then move on to the next lesson.